Hi, in this talk I'll present a platform that may change the way we collaborate and develop cyber-physical systems and beyond. Before the technical part, let me introduce the project that leads to this platform and how you may be able to join us. HUBCAP is an EU project. It started last January and is coordinated by Aarhus University and encompasses this network of digital innovation hubs, SMEs, universities, companies from different countries. And we develop joint efforts to provide a one-stop shop for EU SMEs who provide or want to adopt model-based design techniques in the process of developing cyber-physical systems. In the offering, we expect the network of digital innovation hubs to provide access to digitalization advances and routing of capabilities to their local SMEs and institutions in their environment. We have some seed FMEs, which are already populating the collaboration platform. We have a palette of experts in model-based design, beyond the collaboration platform that I will talk about later, you may be interested in applying to some of our open calls. The project, the project has 3.2 million to distribute to SMEs. So if you are or you know a EU-based SME that may be interested, please pass the message. Either if the interest is to provide tools or models to the platform, or if they want to adopt or try to incorporate model-based development in their processes. Back to the technical part of the talk about the collaboration platform. First, in fact, I just skipped a slide. So the outline is the first thing that I'll try to do is to motivate why we need such a new platform. Then I will talk about the platform itself and what's its main feature, that is the sandbox architecture. And I'll provide a couple of demos about it and conclude this talk. Why would we need such a platform, right? And it looks like on my page down just always skips 2 slides. Sorry for that. So why do we need it? Indeed, the main message is there's a barrier that prevents SMEs to adopt this technology. And it's not only SMEs. So if you try to develop a cyber physical system using model-based design tools and models, you will encounter this challenge. That is, you have to use multiple tools to develop multiple models or different facets of your system, and then there's no one size fits all approach in this process. And you can imagine the number of problems that only combining tools already pose. So this is both evidence from the practical domains, or when you apply this in practice, but it's also what theory says, and it's an outcome of the previous EU into CPS project, where the motto is combine multiple tools in the development of cyber physical systems. And in the case of the into CPS application, a lot of the case studies involve combining continuous models and discrete models for controllers, using different tools like Overture, 20sim, OpenModelica, Architester that provided tests, and these tools generated simulation units that then are jointly simulated to provide behaviors of the whole system. But if this was not enough, indeed, just slow down a little bit here. So I'll make the argument a bit more precise by using a small typical example of what could happen in like kind of the SME that an SME near to you. So an intern gets assigned to develop a cyber-physical model for a project with the local water utility company. And he goes to his supervisor, right? And he says, okay, I was given this assignment, like kind of how should we proceed? And usually the supervisor or a supervisor could just say, okay, oh yeah, we did something like that some time ago, just go and reuse it. And he provides some links, and here goes our intern, and he gets like kind of flooded like kind of with all these kind of models for the discrete controller of a valve, then like kind of the continuous model of the hydraulics of this system, and eventually he may think, okay, indeed this matches my example, so I have an upper and a lower tank. I don't have to on the upper part, but I probably can reuse this model, so I'll try to adapt it. But yeah, so that was the dream. The reality is a bit different. So just to try to install like kind of the tools that supported the model, if it is a reuse case and this model is not currently maintained, eventually you may find that some of the libraries that like kind of the tool or the model requires were deprecated. And this obviously prevents you to run it. Then like kind of there's even like kind of knowledge about how you run this model. So why is it like kind of I'm seeing the instructions and they say that like kind of something should happen in my screen, so the valve should open at this point and I'm not seeing it. There's then like kind of the next level of problems is, okay, how can I adapt the previous model to fit my new case? So you have to have another level of understanding to adapt the model or to particularize it or specialize it to your new case study or your new scenario. And then you may even find the usual issues about, well, this was a model produced at a different project with different partners. It was a collaboration. Who owns the different models? Do I need to pay a license? Can I just like kind of look at the model and make it run again like kind of without having to pay any license? And HUBCAP to the rescue, in fact. The main goal is to avoid all the above, and whatever you may have as well. If there's in the audience, if there's professionals that try to replicate or that been into the process that I just described, they will probably have a lot of gory details about how the process of reusing a model can be hampered. But basically, HUBCAP tries to simply address all the problems that was listed, or the ones that we can easily tame by just providing the models and the tools in a platform, and they are all packaged and ready to run in the HUBCAP sandbox. And in addition to that, we have the ecosystem. So basically this network of digital innovation hubs and experts and the partners that provide and know about the usage of the tools that can allow you to get to your development level faster. And it also has a motto that like kind of what is in the platform should be pay as you go. So you should not be paying a big license before you experiment with the model, and then you check if indeed it adapts to your problem. And well, at this point, I think I can just start showing what exists already. So this is online. It's the platform itself. Basically provides you a catalog of models and tools. So a registered user can just click on it and check what are the tools available. So we have Into CPS, Overture, Autofocus, Modelica, Okra, and XUP. and we expect to have much more. Then models that can be reused run in the tools that are in the tools catalog. So the 3-tank water tank, that is basically the Overture 20sim, Open Modelica, and other tools supported case study that came from the InterCPS app or InterCPS project, and several other models. All of these are just listed. It could be our intern would just grab those from the internet and try to install themselves. Where we go further and where the collaboration will be pushed forward or better enabled is the aspect of the sandbox that the platform will provide or provides. That is basically it just launches these boxes that I show in this diagram over here with the software boilerplate, so operating system dependencies for each tool to run a particular model. So basically, from the models, tools, catalogs, different users can bring to life their own sandbox, their own development environment, ready to use. And well, the pay-as-you-go part is still under development. But at least during the project, we can just use it as it is. So now I'll provide an example of launching 2 tools in this sandbox. So I'll just, yeah, so here we're just accessing the platform. There's this landing page, and I think at some point, yeah, you can select some operating systems, and you can create your own sandbox with your own tool just by launching that operating system and installing your tool on it. There's the tools catalog and the models. And now as an example, yeah, I had 2 sandboxes created a couple of days ago, and I'm adding 2 tools. And it's the InterCPS tool and the Overture tool and a tutorial that we use in the InterCPS application training sessions. So basically, this is a website, so portal. So it takes a while it prepares the whole environment, the VLANs, the network file system, the different virtual machines. But eventually, we will get to see the current aspect of a sandbox. So basically, so here's the InterCPS tool and the Overture tool now as 2 views of these environments where everything is ready for you to interact with the tools and the model that you specified. Okay, so let me just move this back. Yeah. So basically what we saw was indeed the launching of one of these boxes with a dedicated VLAN, 2 virtual OSs or 2 Linux machines, one with the InterCPS, one with Overture, and in fact they share one model, that is the tutorial one for the InterCPS tool that has a submodel for Overture. And that's not just it. It's not just like kind of software ready to use. It's also like kind of this new paradigm, or what we expect to be a revolution in how you cooperate. So glimpse of that. Sorry for the clumsiness, but the sandbox is it's a prototype. It's running live, but not usable yet. We assume it will be later this year. But Here would be our intern looking at the into CPS example for the water tanks. He's inspecting the, checking it if like kind of it would fit his local water utility company case study. He eventually discovers that there's an associated overture model, and in fact he launched it. But yeah, he launches the tool. He gets the welcome page. He at some point like kind of it gets a little bit like kind of lost because this tool is not in his usuals. So he goes back to the example. He interacted with the Into CPS tool at some point. So he will try to inspect what is the currently being plotted about this co-simulation of this 3 water tank system. Yeah, well, he's running the tool in a sandbox that runs Linux, and somehow to visualize it, he needs to have the COE launched externally to allow the wine subsystem to take over. But eventually, he runs the tool, and yeah, everything was ready just to run. That's the neatness of the sandbox. It's not that you need to install the tool and its dependencies or its special script when it's running in Wine. But yeah, so eventually he checks the behavior. He would expect that the water in the bottom tank would always be between the 2 loops. And he's well, just checking the behavior if everything works as it should. So plotted like, you know, there's a blue line, what's the level at the bottom tank, and eventually when the water goes next to the top loop in the bottom tank, he would expect to see a decrease in the curve. Well, yeah, the behavior is as expected. Our intern kind of is happy to accomplish his task, but he needs to see the source of the controller. He knows it's in Overture, but he's a bit like kind of unaware on how to see that. It's a requirement of the water utility that he needs to have access to the source code to, I don't know, make sure that everything is according to standard. So he invites Prasad. So Prasad is a colleague. He knows a lot about Overture. Prasad like kind of now has access to this sandbox. And here comes Prasad. So Prasad is in the browser on the left, well, for the demo. So he sees that like kind of Hugo has 2 virtual machines. He goes directly to the Overture. He knows he wants help with it, and he just says somehow like kind of the instruction: if you want to load a project in Overture, you just follow this path. And for the particular case study, you can go to the network file system. You get to the models folder in the Into CPS project. And yeah, you grab the VDM model, you open this project, and yeah, off you go. Yeah, so Prasad is interacting with the sandbox on the left-hand side on a different machine. The sandbox is located in Italy currently, and Hugo is seeing it in his computer at home or at work. Well, coronavirus times he's at home, right? So he checks the model. In fact, there's a small glitch in that model, but it's not a big problem for the demo. Yeah, he's inspecting the source code. Indeed, it's according to the standard of the water utility code standards, or well, he re-exports the FMU. He just wants to make sure that wherever was being shown to him is indeed what this code, what he trusts from the code generated from Overture and the Overture compiler. And yeah, he can just like kind of drop it in the right place, in the FMU's folder. It replaces the previous one. And yeah, and now we can like kind of evaluate it again. So this was it, at least, well, it's the demo that you can do, or I can do, sorry. But we foresee much more to come. So as a conclusion of this talk, I presented HUBCAP, the project itself. I hope that like kind of if you're not an SME but you know one, please pass the message. There's open calls for SMEs interested in providing or adopting models and tools in their processes. And I presented the platform itself that is currently under development, and it will be made available soon. Feel free to join us in via the website, Twitter, or LinkedIn accounts. Thank you to all the project members, in particular to Giuseppe and Pietro, that are like kind of making great efforts to make the prototype of the sandbox available. That we expect that will be running and revolutionizing the way you collaborate in development of cyber-physical systems and beyond after late this year. So thank you very much, and I'm open to your questions.
So any questions to the demonstration that Hugo have made here? Note that I'm recording it, so be aware of that. But comments and questions are welcome. I see a question from Jose about hardware in the loop simulations. We have not yet considered that. I know that Virtual Vehicle, one of the partners, actually have been doing hardware in the loop kind of capabilities, but we have not moved there yet with respect to HUBCAP. Other questions, comments? If not, Frank, do you want to take over the screen?
Yes.